Hi guys, welcome to another lesson. If you want to do your do now questions, please pause the video here and try them on your own. I'll go over the answers in a little second. I'll just read out the questions now so we know what we're doing. Number 1. What was the study of chemicals and concoctions known as before it was called modern chemistry? So what did we call the study of chemicals and concoctions before we called it modern chemistry? Number 2, what do farmers use calcium carbonate for? What do farmers use calcium carbonate for? And 3, acetylene is capable of producing an extremely hot flame. What job uses acetylene? Acetylene is capable of producing an extremely hot flame. What job uses acetylene? If you want to try those on your own, pause the video now, give them an attempt. I'll just show the answers now. So, question number 1, what was the study of chemicals and concoctions known as before we called it modern chemistry? And this was alchemy. So I spoke about alchemy being something that was quite mystical, that was used by people before the proper scientific revolution took place. And alchemy was similar to chemistry in that you were taking substances, mixing them together and seeing what you got. But it wasn't quite scientific. What do farmers use calcium carbonate for in farms? They use it to neutralise the soil. I'm going to be talking about that a little bit more today. What do I mean by neutralise? Neutralising what? And acetylene is capable of producing an extremely hot flame. What job uses acetylene? And the answer was welding. So if next time you see a table, I think at the school, if you see the school tables, the metal joints look like they've been melted together, and they have, and that's through welding. And we're using this element because it can produce extremely hot temperatures. Okay, I briefly mentioned this in the last lesson about pH, and mainly when I was talking about the use of carbonate on the soil. So you may have or may not have came across pH before, and what you'll see here is a pH scale, and pH is a measure of how acidic or how basic an element is, or a compound is, or a mixture is. So strong acids are way down, maybe 1 being one of the strongest, which hydrochloric acid, which we have in our stomach, is here, and then we have really alkaline or base elements or compounds up this side here, like ammonia, bleach, and oven cleaner. So we use the word base and alkali kind of interchangeably when we're talking about pH, but everything below 7 is what we'd consider acidic. Everything above 7 is considered basic or alkali. And 7 itself is considered neutral. It's neither acidic or basic. And number 7 is pure water. So pure water is neutral. So we're going to talk about this at length today. So in the last lesson, I mentioned calcium carbonate can be used to neutralize soil. What did I really mean by neutralization? Well, pH, as I said, is a measure of how acidic or basic something is. And pH is measured on a scale of 1 to 14. Like I say, acids range from 1 to 6.9 really, and bases go from 8 to 14. Pure water is neutral, so it's neither an acid or a base, and that's 7 on the pH scale. Base is a substance which can be used to neutralize an acid. So base and alkali are the same sort of thing. So an alkali is a special type of base which dissolves in water. Not all bases are alkali because not all bases dissolve in water, but you'll hear that a lot of people will just use that interchangeably. So when we have an alkali, it dissolves in the water, and that is good for neutralizing acids. So neutralizing acid is bringing the pH up so it's not as acidic anymore. So by adding something that is alkali to something that is acidic, you can raise the pH and make it less acidic. And that's what we're talking about when we're talking about the farming. One of the strongest acids that we know of is hydrochloric acid, which has a pH of 1. And we actually have hydrochloric acid within us, and the acid in our stomachs would be extremely dangerous if it wasn't housed within our stomachs. And if anyone's ever had heartburn before or been sick, you know that it really hurts your throat. And one of the main reasons it hurts your throat is you have really an extremely strong acid burning the lining of your insides. Why doesn't it feel like burning all the time? Well, the stomach that you have has evolved over thousands of years, and the stomach has a special wall, and the stomach cells actually continually die and are replaced because the acid is so strong. But we have this special organ that can house the acid. The reason acid is so strong is so we can digest food and literally dissolve it. So you imagine an acid dissolving something. That's how strong this acid is. So how does your stomach deal with this? Like I've said, so the pH inside human cells is 6.8 and the pH of blood is 7.4. Both are very close to neutral. Extreme pH values, either above or below 7, are usually considered unfavourable for life. However, the environment inside your stomach is highly acidic with a pH of 1 to 2. How does the stomach get around this problem? I've just told you the answer is disposable cells. Stomach cells, particularly those that come into direct contact with stomach acid and food, are constantly dying and being replaced by new ones. In fact, the lining of the human stomach is completely replaced about every 7 to 10 days. So that's crazy that that's happening without you thinking about it. But if it didn't happen, then you'd be in serious trouble because it is such a such a low pH, so it's such a strong acid. Other acids that we are talking about that come naturally, that are less harmful than hydrochloric, is citric acid. So citric acid you've probably heard of before if you think of citrus fruits, and it has a pH of around 2.2, and it's a natural preservative and is also added to a lot of foods. So if you look at any soft drinks, anything that's quite sweet, you will often find on the label that citric acid has been added to enhance the flavour, and not only to enhance the flavour but allow the product to last longer. So the pH values of some common substances. So you may recognise some of these substances in your own house. Right at the bottom here, really strong acid, we have hydrochloric acid, followed by citric acid in lemons and oranges. Then you have your sugary drinks like Coca-Cola, vinegar. Again, they're quite between strong and weak acids. Black coffee is slightly acidic as well. Milk is quite surprising. So when you burn your mouth, for example, if you eat a really hot chili, most people will say, okay, drink a lot of milk. And milk does have a kind of neutralising effect because it's cold and it's thick. But you might be quite surprised to understand that milk is actually slightly acidic. You may have thought because it has those sort of cooling properties it might be on this side of the pH scale, but it's actually considered a weak, very, very weak acidic mixture. Then in 7 we have neutral, which is pure water. Then above this we have the bases. So we have Colgate toothpaste, bicarbonate of soda, which you've seen already. Seawater is not acidic, it is basic. Brasso, so we're talking about cleaning products, and you'll see a lot of these cleaning products are weak to strong bases. And you may, if you use particularly strong cleaning products, they always say wear rubber gloves because these can still have a harmful effect on your skin. A lot of people think there's a misconception that acids are bad for you, so bases would not be, but anything in these high concentrations neither one is very good for you at all. So you want to be kind of not using this, allow it to touch your skin because it can cause damage and cause irritation. So back to the farming one, I've mentioned that a few times. So calcium carbonate is also called lime. We're not talking about the fruit. It's just the name that's given to calcium carbonate. So people will spread lime on their fields to increase or neutralise the soil. So why would they use calcium carbonate? Well, if you have a soil pH, so the pH of your soil, if you're a farmer and you go out and do a test, if the pH of your soil is below about 5.5, then you're getting worried because that's quite acidic. What you really want to do is bring that number back up the scale. So calcium carbonate here you can see is just under 10, so it's a weak base. When it's dissolved in water we can use it as well. and this would bring the soil pH up. Why would you want to bring the soil pH up? Well, really acidic soils are not conducive to growing crops. So I mentioned that in the last lesson. If you have a really acidic soil, then you're not going to grow much on there. And that includes grass as well. So if you're grazing animals on a pasture and the grass isn't growing that well, then it's still an issue. So you'd probably want to try and solve that issue. So just a little example here. Here is an area that was treated with lime, so calcium carbonate, and given fertilizer, and no soil amendment. So nothing happened in this area here. No lime and no fertilizer. And you can see the difference, okay? If you had a head of cattle or you had some sheep, you'd want them to be grazing in this. This is going to run out very quickly and you're going to have a lot of hungry animals. So it is a big job. If you think you have a lot of acreage, throwing lime down is not something that you want to do every single day. But if you want to bring your pH back up so it's not as acidic, then you're going to increase the yield of plants that are going to grow in your property. So it's interesting, that's just related to pH. You're not doing anything else there. Okay, so as lime dissolves in the soil, calcium, remember it's calcium carbonate, moves to the surface of the soil particles, replacing the acidity. The acidity reacts with the carbonate, CO3, to form carbon dioxide and water. The result is a soil that is less acidic has a higher pH. So this is called a neutralization reaction. You've neutralized the soil to an extent to make it less acidic. Okay, so really important if any of you guys are living on the land or thinking about it in the future. This is something you'll probably come across in your future careers. So as a farmer, how do they know what pH their soil is? Well, there's a bunch of instruments that you can use and technologies. But the easiest one, the most simple one, is using indicators. So the pH of a substance can be measured using a pH meter, which we have here in the bottom right, or liquids called indicators, which is up here. Indicators change colour depending upon the pH of the substance in which they are placed. The colour ranges of a number of different indicators over the pH range 1 to 10 are shown below. So if you look at this little wheel, if I used a universal indicator, it's called, and say a bit of soil, crushed it down, put it in some water, and then put the indicator in, the colour would change, the indicator would react with the hydrogen. We'll talk about that in a little second. But the indicator will react and it will change colour. So if I have a really strong acid, about 1 or 2, it will go kind of pink. Weaker acid, it'll be about deep orange, lighter orange, beige. Then when we get past the neutral 7, it's going to turn green and eventually blue. And you can see that quite nicely in this scale here. And if you remember in term 1, we talked about the wavelength spectrum of light. It is the same spectrum here. So you have red on one side and blue on the other. And as we move through this, red being highly acidic, purple, ultraviolet almost, is highly alkaline or basic. So universal indicator is a mixture of indicator substances that changes colour over the full range of pH from 1 to 14 as the strength of an acid or base changes. It is pink in strong acid, a pH of 1, or blue in a strong base, and green in neutral solutions. So hopefully when we get back to class we can look at this in person. It's quite interesting. We'll get some household items, okay? We'll look at some bleach, some soapy water, we can look at rainwater, we can look at some Coca-Cola, coffees, and we can check the pH against them all and see if we can measure any differences. Now, one thing that I'm going to mention here that is something that you're going to look at extensively in year 11 is it's quite tricky to always come up with the same result when we use colours to measure things. So you imagine if I look here and look at baking soda and I said, yeah, it's probably got a pH of 9, but somebody looks at it and it looks slightly darker to them. They make 9.5 or they might even say 10. It's quite difficult to get an accurate number for pH when you use colour because colour is subjective and it's not as accurate as using, say, a pH meter which tells me exactly, okay, this liquid has a pH of 7.77. So you can't get much more accurate than that. And these two types of data, so the colour data is called qualitative data because we're using letters to describe the information. We're using letters like blue, green, yellow, or red. And the pH meter is an example of quantitative data. So they sound very similar, but the key difference there for quantitative is there's an N, and the N I always like to think stands for numbers. So quantitative data always gives you a number, qualitative data is just a word. So for myself, all my training was in quantitative data analysis, and qualitative data is still fantastic, but for different subjects. So more like the humanities, if you're interviewing people, for example, and asking them questions, that'd be an example of qualitative. If I was measuring the heart rate using a heart rate monitor, that would be quantitative data. So I'm just planting a few seeds just now. Don't worry about remembering all of that, but we will talk about that a lot more in year 11. Okay, now that we've went through that, I think it'd be worthwhile if we assess what we've learned so far. So you should have this in your workbook. We can do it together. But if you want to pause the video here and attempt it if you haven't already, and really just see what you've got, if you've understood this, and if you want to go through the answers, then resume the video. I'll go over them in just a second. Okay, so question number 1. The pH scale is associated with acids and bases. Acids and bases. So we know that we're measuring the pH of something that's going to tell me if it's acidic, basic, or neutral. And it's important for a whole bunch of reasons. We've got a few examples there. The good one is acidic soil is not very good for growing crops. So we want to bring that pH back up to a more neutral number. pH stands for, and I haven't put it in here, but I spoke about it very, very, very briefly. pH stands for potential hydrogen. That's what pH stands for. We don't need to know the ins and outs of it at the moment. We might revisit this in another day. But pH stands for potential hydrogen. Number 3, alkaline or alkali is another word for bases. Alkaline or alkali is another word for bases. Number 4, water is blank. It has a pH of 7. So anything that has a pH of 7 is neutral. It's neither acidic nor basic. Number 5, on the pH scale, blank are found from 1 to 7 and blank are found from 7 to 14. So what are found at 1 to 7? Well, we talked about that. Acids are found between 1 and 7. Hydrochloric acid is very, very strong, and that is found at pH of 1. And blank are found from 7 to 14. That is our bases. Our bases are found above 7. The acid our body uses to digest food is, I've just said it there, the acid our body uses to digest food is hydrochloric acid. Very, very strong acid. Good for our stomachs to break things down, not good anywhere else in the body. And number 7, blank acid is present in citrus fruits such as oranges and lemons. Blank acid is present in citrus fruits such as oranges and lemons. That is citric acid. And again, I challenge you to look at some of your household items or stuff that you're eating. See if it has citric acid. It's in lots of products because it does change the flavour, but it can also increase the lifespan of a product as a preservative. And number 8, we measure pH mainly using indicators. So that's when we put an indicator in and it changes colour. And as I said, hopefully when we get back to the lab, you guys will get to do this for real. The last thing I want you to do, and I do want you to pause the video and try this on your own before we look at the answer, I want you to arrange the following from the most acidic, that should say, to most basic. So we've got black coffee, toothpaste, seawater, Coca-Cola, milk, hydrochloric acid, pure water, and ammonia. What I want you to do is look. So we see where's black coffee here. Nope, arrange the following from most acidic to basic. So we want to start with whatever is down here, the most acidic. So we'd have hydrochloric acid would be the first one here. Then we'd go up. What would be next? Black water, toothpaste, seawater, Coca-Cola, milk, hydrochloric acid, pure water, ammonia. It'd be Coca-Cola. It's here. What else do we have? Then it would be black coffee. Okay, so I want you to look at those and have an attempt yourself. So maybe pause the video here and write it out in that order. Okay. So we have hydrochloric acid with a pH of about 1, Coca-Cola between 2 and 3, black coffee between 5 and 6, milk between 6 and 7, pure water is neutral at 7. Then we have bases, toothpaste between 7 and 9, seawater, which is about 9, and ammonia, which is anywhere from 12 to 13. So hopefully you've put them in the correct order, and you can see here the pH scale and where different substances lie on that. And again, hopefully we get to do some of this in the lab sometime soon. Because we're talking about the body today, Hamish has got this amazing fact. The skin is the body's largest organ. So a lot of people don't realise that our skin is considered an organ, and it's the largest one. So you never know, that might get you points in a quiz one day. But thank you very much, guys. I'll see you in the next one.